Hello, my dear students. Welcome to the new course on inorganic semi-micro analysis, commonly known as salt analysis. Salt analysis, the chemistry of identifying the unknown. A series of video will come in this course on the systematic analysis of the salt by semi-micro technique. This is the introductory video where I'll give you the content of this course. So let's start the start video. What is salt? We know that salt is the product of the reaction between acid and base. So any salt, say here it is sodium hydroxide and hydrochloric acid form the salt sodium chloride. So any salt has two parts. One is the acidic part or anion and another one is the basic part or the cation. This basic part or this cation comes from the base. That's why it is known as the basic radical. And this anionic part comes from the acid. That's why it is also known as the acidic radicals. So any salt is consisting of one cation and anion, and salt analysis means identification of these cations and anions present in the salt. So salt analysis is a systematic method used to detect and identify the cations, that is basic radicals, and anions, that is acid radicals, present in an unknown inorganic salt. Now coming to the inorganic semi-micro analysis. There are three techniques of analysis of the inorganic salt. One is microanalysis, where the quantity of the sample taken is very small, less than 1 milligram. Here generally we use the equipments. This is instrumental analysis. Another one is macro analysis, where large quantity of the sample is taken, say 0.5 to 1 gram. Semi-micro technique falls between the two. Here the amount of the sample taken will be 20 to 100 milligram and the solution volume will be 1 to 3 milliliter. And so inorganic semi-micro analysis is the science of identifying cations and anions using small quantity of the chemicals through systematic qualitative test, forming the foundation of analytical chemistry. Now, why semi-micro analysis? Why it is superior to macro analysis? In semi-micro analysis, sample required is less, so reagent required also will be less. Therefore, it is cost effective, less amount of sample, less amount of reagents are required. So, economically it is beneficial, it is cost effective, and as less amount is required, as the reactions taking place between small quantities, so time taken is less, and already I told cost is low, and the waste product generated in this reaction also will be less. It will be easy to dispose the waste material, and it is ideal for the scarce and precious samples. Whereas in macro analysis, large volume, large quantities are taken, so time taken will be more, and more amount of chemicals, reagents, and the samples are required. So it is highly costly, and the waste generated also will be more, and it is not preferable for the sample which are not easily available, that is the scarce sample. So semi-micro analysis is superior to this macro analysis. Now coming to the what all the topics will be covered in this course. First one, laboratory safety and precaution, apparatus used in semi-micro analysis, list of cations and anions identified by semi-micro analysis, preliminary examination of salts, detection of anions, detection of cations, group separation of cations, confirmatory test, recording observations and drawing conclusions, analysis of mixed and unknown salts. So let's see. First topic was laboratory safety and precaution. So any chemistry laboratory, whether it is in educational institution, it is in industry, or it is in the research lab, some safety norms or safety rules we have to follow. All of you are aware of this, but still I'm making the videos on this practical chemistry, so I have to make a short discussion on it. First one is personal protective equipment. You have to wear this lab coat, gloves, and that goggles, and the shoes that cover your feet. Then chemical safety, you should not test any chemicals. You should read the label of the chemicals carefully, and for any toxic chemicals or hazardous reaction, you should perform it under, that is under the fume hood. Okay, that's all. And then the safety handling of the glasswares and equipment. There should not, we should check it. There should not be any crack in the glasswares, and these glasswares you should generally you should hold by these tongs. And whenever you're using any equipment, say balance or any other equipment, centrifuge, you should uh, follow the instruction given in the manual. Then the fire safety, you should know the location of the fire extinguisher, blankets, and emergency exit. And any inflammable chemicals, you should not keep it near the burner. Okay, and you should not these things, that is, turn off the gas and electrical equipments after use. Okay. Next is the electrical safety. You should not touch an electrical switch, plug, anything by the wet hand. And waste disposal, which is very, very important. Dispose the chemical waste according to the laboratory guidelines. Okay. And this hazardous waste, we should not directly pour it into the sink. If it is hazardous, you have to follow the separate that disposal procedure, or you have to convert it into the less hazardous substance and throw it to the sink. Then emergency preparedness, be familiar with the emergency procedures and evacuation routes. That is very important. And for semi-micro analysis, the precautions, that is that small quantity of chemicals you have to take and handle this apparatus and chemicals very carefully. Okay, and you have to use the very small quantity of reagent with the droppers and avoid any contamination of these reagents or chemicals. Okay, and perform this test, which involves the evolution of hazardous gas under fume hood. Okay, that's all. So these are the laboratory safety rules. Then coming to the set of inorganic semi-micro analysis apparatus. So here we'll take the set of test tubes which are smaller size compared to standard test tube. Length will be 10 centimeter, diameter is 1 centimeter, and then wash bottle also 125 milliliter, beakers smaller beaker 50 milliliter, measuring cylinder 10 milliliter, and here filtration is replaced by centrifuge, so you have to use the centrifuge machine with centrifuge tube. And then these are the common thing: porcelain dish, crucible, watch glass, and the white tiles, smaller white tiles to make out the color properly, to observe the color properly. And generally perform the conformity test in the spot plate here. Okay, and these are the other common things, that is the wire gauge, then brush for cleaning the test tubes, and small spatula, and obviously the droppers, because in semi-micro analysis very less amount of reagents are used, so you have to use the droppers. And then you have to use the semi-micro boiling tube, which is a small boiling tube. The size will be 60 millimeter length and 15 millimeter this diameter. That is the semi-micro boiling tube. Now coming to the second topic which will be discussed: what are the cations and anions can be identified by semi-micro analysis. That means what are the test of cations and anions will be discussed in these videos. So anions, first anions are divided into two groups, group A and group B. Group A anions are divided into two subgroups, that is group A1 and group A2. Group A1, which are decomposed by dilute acid, dilute hydrochloric or sulfuric acid. And the anions coming under this group: carbonate, bicarbonate, sulfide, thiosulfate, nitrite, and acetate. Then coming to the group A, second subgroup, where it is detected by concentrated sulfuric acid, and here the announcer chloride, bromide, iodide, nitrate. All these tests we will discuss. Then group B, where the special tests are required, that is here under this sulfate, phosphate, borate, oxalate, fluoride, chromate, arsenate, arsenite and permanganate. Now coming to the list of cations identified by semi-microanalysis. In inorganic semi-microanalysis, cations are divided or classified into groups, okay, based on their reaction with the specific group reagent. The first one, group 1, known as the silver group, where the group reagent is dilute hydrochloric acid and cations are precipitated as chloride. Under this, you have silver, lead and mercurous. Then coming to group 2, where the group reagent is your hydrogen sulfide gas in acid medium, and the precipitates are formed in the form of sulfide. Here the cations are cupric, cadmium, bismuth, mercury, lead, arsenous and arsenic, antimonite plus T plus 5 and tin, that is tannous and stannic. Then coming to the group 3, that is called iron group. Here the group reagent is ammonium chloride solid and ammonium hydroxide. Precipitates are appeared in the form of hydroxide. Here you have ferric, aluminium and chromium. Then coming to group 4, where the reagent is this hydrogen sulfide gas in alkaline medium. Here also precipitates are formed. Group precipitates are formed in the form of sulfide. Here we have zinc, manganese, nickel, cobalt. Next, group 5, where the group reagent is ammonium carbonate and group precipitates are carbonate. Here the cations are barium, strontium, calcium. And finally, the group 6, alkali group, it remain in solution and are identified by specific test. Here we have magnesium, sodium, potassium and ammonium. Now what is the outcome? At the end of this course, you will be able to do systematically the detection of acidic and basic radical present in an unknown inorganic salt and understand the chemistry behind it. That means understand the type of reaction, understand the chemical equation, specific chemical reaction and with equations. Okay, not only the single salt, you'll be able to analyze the mixture of salt also. And finally, the conclusion, inorganic semi-microanalysis is a systematic, economical and environmentally friendly method for identifying inorganic ions. It serves as a fundamental tool in education, industry, environmental studies, forensic science and research laboratories. So with this, we have come to the end of this video and hope these videos will be useful for you. And with this, and stay connected with me. With this, I close this one. Thank you.